what have we been doing lately? We've been solving for sides and solving for angles and for area. And we call this solving triangles. You can see the sine rule over there. You can write the sine rule with the focus being on the angle. So then you would write the sine of the angle on top. Or you could write it with the side opposite the angle being on the top. But this is still called the sine rule. And then there's something called the area rule, which helps you find the area of triangles. And then last time we used the cosine rule or the cos rule to find basically when you were given a situation where you had like two sides and then you had another side that you wanted to work out. Basically what we did was we said, look, as long as we had two sides and the angle in between those two sides, we could work out this third side. And we used this cos rule idea over here. So give me a thumbs up if that looks familiar to you. Give me a thumbs down if something doesn't look familiar. It's also helpful for me to see from the profile of the class what speed I should go at. So thumbs up if you feel like it looks familiar. Thumbs down if you like, it looks Greek to me. Okay, because remember, I don't always have access to your visual feedback, so the clicking thumb feedback is super helpful, so I get a sense of class feeling. Okay, let's go. So what are we going to do tonight? So just like with the sine rule, sometimes you can write it where you focus on the sides. So like with the sine rule, what I told you when we did it is if you're trying to find a side, you write the side first on top, and then you write the sine of the angle on the bottom. Okay, so that's if you're trying to find sides with the sine rule. If you wanted to find angles with the sine rule, you normally wrote it like this, because you could focus then on the angles. And so even though it's the same rule, it could be written in two different ways. Now, the same thing kind of applies to the cos rule. Okay, the one that you learned about in the last lesson was if you're given two sides and the included angle and you want to find the sides, then this is a great way to write it. But if you are given three sides and you need to find an angle, then writing it like this, it makes it difficult to get the angle or the cos of the angle. And so what we do is we take this and we rewrite it in a way that makes our life easy. So the first thing I'm going to do is I'm going to move the minus 2ab cos c to the other side, and I'm going to get 2ab cos c, and then I'm going to have plus c squared equals a squared plus b squared. So I've just moved this one around and got this. Give me a thumbs up if you understand that first manipulation I did. Okay. Now, because my hope is to get this by itself, but this is getting in the way. So I'm going to move it to the other side, and I'm going to get 2ab cos c equals a squared plus b squared minus c squared. So I've now moved this around. And remember that these things are all sides. They're sides in the triangle. And there's also sides over there. And this one over here is the angle. So I'll give it a little hat. The last step I need to deal with is the fact that the 2ab is getting in the way of the cos c being the focus of attention. And so the cos of c is equal to a squared plus b squared minus c squared over 2ab, which is what we wrote here. Now, the best way to understand the cos rule in terms of angles is not to memorize this. It's to understand the relationship between the different sides and angles. So before I let you do this, I'm going to show you how I would work it out in this question over here as an example. So here is a triangle with sides A, with vertices A, B, and C. In terms of the terminology that we use, this would be little a, this would be little b, this would be little c. Okay? Now, if I wanted to use the cos rule to find an angle, let's say I wanted to find the angle C. In this scenario, how do we apply this different form of the cos rule? And you start by simply writing the cos of the angle you're trying to find. So that's step one. Step two is to realize on the other side, we have a fraction. Now, this fraction is going to have lots of squares in it. So what I'm going to do is I'm just going to write some placeholders. So that's the basic structure. But the thing that is very interesting is that what is the side that is opposite the angle that you are trying to find? And the angle that I was trying to find was this green dot. Opposite this side is the 5. And the thing that is opposite is going to be the one where there's a minus. So you'll notice in the setting, there's a squared plus a squared and then a minus. The minus is always going to be the side opposite the angle you're trying to find. Then, what are the other two sides that are involved? These two sides, I call them the arms of the angle. So the angle that you're trying to find is the green dot. That is one arm of the angle. This is another arm of the angle that you're trying to find. And they take out the two other spaces. So I'm going to put a 9 and an 11 and a 9 and an 11. And so this is the cos rule written in terms of making the angle the focus. Now, which of these 4 options from the question looks right to you? Which of the ones matches my one here? Let me know in the chat. Which one matches my one here? Okay, so the one that matches my one is actually this one. But you notice that they've got 11 times 9 and 11 and a 9 here. The good news is it doesn't matter as long as I have both of them here. It doesn't matter if I wrote an 11 and 9 or because adding to things like this is commutative and so is timesing. So you're quite correct that B would be the correct answer, but we still haven't found the angle C. Now, in order to find the angle C, what do I still need to do to my equation? Maybe someone can tell me in the chat if you are feeling generous with your knowledge. Chantal, let's unmute Chantal. What can you tell us, Chantal?
Sir, I'm not giving an answer, but then I can't see what you're talking about.
Aha. Can I suggest you speak to Kia in the chat with a direct message, and she will sort you out as best she can, because there might be a technical issue, maybe.
Sir, I typed in the message, but then it doesn't.
Hello? Maybe there's some audio. Oh, did you type in a message? Okay.
Yes, but then it doesn't show if it's sent or anything. It just types in that there's no button.
Can I suggest we just keep trying there, and then Kia will guide you as we go through the lesson. I'm sure we'll sort it out shortly. Okay. So Oratile, what do you have as a question or comment, or do you know how to find C?
I know how to find good evening, sir.
Hey, what would you do?
So I'd shift cos to the right hand side and it would become cos I forgot her. Well,
Inverse cos.
I forgot the name after you shifted.
Yeah, inverse cos.
Then it would become cos. Yeah, inverse cos. Yes, sir. Thank you.
Pleasure. And then you basically just put the fraction in your calculator, and you should get, can you put the answers that you guys get in the chat? And then I will reveal my calculator now in a moment. Let me just do that. So I've done that, and I need to close my bracket. And what I get is I have inverse cos, and then I have this. And if I hit equals, I should get 26.63. So that angle that I was finding at the beginning is 26.63. Now, you need to practice this. So we're going to do a few more now. So I'll leave that one up, and then I'm going to give you another one that you can practice by using that idea. Let me quickly get this. And I want you to find me the size of angle A over here. And I will leave up the working out from the previous question just to help you a little bit. So find me the size of angle A, and you start by doing that. That's my tip to you. And if there are any questions, you can keep checking there, or keep those hands coming with the questions. I do think one of the cool things about our class is the flexibility we have with questions. And especially now when the students are working, it's a great time to chat about etc. Well, there's some hands going up there. Oh, we're all just working. Cool. Just keep swimming, I say. So I think the most difficult part of this is recognizing the side that is opposite the angle that I want. So the 7 is the one that is the negative, and then the arms of the angle are just going to be here, 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 here. But we still need to use our calculator, so I'm going to give you some more time to practice that. So shift cos fraction over 2 times 5 times 8. And you should get that A is 60 degrees. Yes, Awami. Yes, and Paul. Give me a thumbs up in the chat if you're following how to use the cos rule, where you make the angle the focus of the formula. Give me a thumbs down if you're still feeling a bit confused. And it's totally fine if you are. I just want to get a feel for the group in terms of how we're doing generally. Let's do a multiple choice question. That'll also help me understand how everyone is feeling. So you're given the following triangle, and it says which of the following is a correct equation based on the diagram on the right. You'll notice that you're given 3 sides in the triangle. Which one do you think fits to build an equation that will help you find that angle? So that's the angle I want to find. Well, to know what's, when you're writing this out, it can seem a bit confusing, but the shortcut is to know the side that's opposite. And then you're going to have a fraction, And within that fraction, you're going to have this structure. And opposite the x is the 13, and that's the exciting part of the formula. And the rest is really not that exciting. So is there one that looks like that? Okay, it can't be that, because the minus 13 squared is what, oh yeah, that gives it away. It must be D. Okay. That's Capozzo, Lebo, and Mompilo. That's looking good to me. Let's do another one of these. Find me angle theta in this triangle. So everyone, if you can find me angle theta in this triangle. And I'm not going to give you too much help unless I receive a question. Otherwise, I'm going to believe in you and let you fly solo. So okay, now answer. If I look at the chat, lots of students are saying 32.16. Let's see if I agree. I agree. 32.16. Okay. So that's going to be 32.16. So I do feel as if we are figuring this out. Let's try another multiple choice just to spice things, keep it interesting. Which of these four options do you think is the correct step when going from this step in the solving for x thing, right? So I'm solving for x. Where do I go from here? Which of the four do you think is? Yo, you guys are, it feels like you're getting more confident. It's like you're like, listen, don't give us such easy things. But it's a sign of your increased understanding. So just to kind of emphasize what happened there is that when you want to get x by itself, you need to apply inverse cos. And so that's the cos that looks like this. You're basically applying it to this side and you're applying it to this side. And then it basically knocks that out and you get left with just the inverse cos and then this. And so it's going to be C. Cool. Let's do one with fractions because we know that, sometimes fractions can mess things up a little bit. So can you find me the value of the angle RST? So RST, that's this angle here. Find me the value of, which one do you think is correct? How are we doing there? Okay, let's see what I get. No, that's not right. Did I make a mistake there? I must have, because that cannot be right. 2, 7 squared plus 8.9. Oh, that's where I made a mistake. Minus 6.4 squared over 2 times 7 times 8.9. Look at that, Ed. It's easy to make a silly calculator mistake. 45.55, which would be C. So that's the correct one. Okay, everyone. I feel like we've done a good solid first half and it's time for a break. So let us leave our seats. Let us stand up and take care of our bodies and our brains. It's like anything in life. You've got to take care of things if you want them to perform over the long term. So let's just stand up and stretch and maybe just turn your body around a little bit. Let it swing around. Oh, this feels fantastic. And then swing your arms a little bit. Shake them out. Shake out your legs. And then I want to give your eyes a break. So what we're going to do is we're going to do this stretch, but while we do it, we look off into the distance and we make sure we're focusing on something far away so our eyes can get away from that short focusing we do on the computer. Then switch to the opposite arm and look somewhere nice and far away. Give your eyes a break. Okay. And then what I want to do is try something new. So we're going to do some eye exercises while we're rolling our shoulders. So we roll our shoulders and then we're going to look up. Actually, we're not going to move our necks. We're going to just look up. This is too complicated for me. I need to do one at a time. So look up with your eyes, and then look down with your eyes, then look to the side, then look to the other side. Look up, down, right, left. Okay, that's apparently very good for your eyes. Okay, let's do some rolling of our shoulders. I couldn't do two things at once. It was too complicated for me. And let's roll forward. And then let us do some tricep stretches. So we'll do like this. And then let's do like this. Oh, that feels good. Okay, what else do we need to do? I think that's fine on general stretching. Let's take some deep breaths. One more deep breath. Yeah, you should feel the oxygen permeating your body. And then let's do some heart rate raising stuff so that the blood can move around your body. We are going to do jumping jacks. So jumping jack is where you go like this, and we're going to do 20 of them. And we're going to start in 3, 2, 1. Let's go. 6, 7, 8, 13, 15, 16, 19, and 20. And I can definitely feel my heart rate is moving. And then today's yeah, I can definitely feel it. Not too difficult to puzzle. Can you tell me what the value of each of these characters is going to be? It's actually not so bad. Today's like an easy brain break. Get those answers coming in. Okay. So the bits must be 10, and the fox must be, thank you, Beverly, it must be 20. The fox must be 20. I see that, yes, so I'm looking at the Kayla, yep, I agree. Yeah, so that's all looking good to me. Kitso agrees. Fantastic. Okay, so that is the end of the break. How are you feeling? Are you feeling like the exercise made you a little bit unwound? Do you feel ready for the second half? Let me know in the chat whether the exercise break has done its magic or you're just still very cold. Okay. Yeah, so second half is always harder just because of the also because of the fatigue factor. But that's why we do the exercises to kind of get our body, tell our body, please reset. Okay, now let's start with this one. Calculate the smallest angle in the triangle. And there are no labels of A, B, and C. So does anybody know, how do we know which of these is the smallest angle? Who has some ideas or some tips or some knowledge that they've learned about that maybe they could bring to the table for the team? So the angle opposite the smallest side is the smallest. Yes, Impol. Yes, Nompilo. You guys are bringing the wisdom. So in a triangle, the biggest side is opposite the biggest angle. The smallest side is opposite the smallest angle. Now, this drawing is not to scale. It's a little bit distorted if I look at it visually, but I'm going to say this is angle X, and this is the angle opposite the smallest side. So this is the angle that I want you to try and find for me. So use what you've learned in the first half of the lesson and see if you can find the angle X. I always like to start with a certain format, because that's the thing that is almost always, well, is always going to be the same if I'm using the cos rule with 3 sides. What angle do you think we get for angle X? So we're going to put a 9 here, and then a 13 and 17, a 13 and 17. And I can see quite clearly in the chat that I get 31.47 degrees. Now, I'm going to ask you now to find the biggest angle in the triangle, which is angle Y. And then I also want you, after you found angle Y for me, I want you to find angle Z, but I don't want you to use the cos rule. I want you to use anything else you can to find the quickest way you can do to find Z, but don't use the cos rule. So what do you get for these 2 angles? Yes, Beverly, well done. So Z will be, you'll use angles in a triangle, but first you have to find what Y is. So what happens is you have to move the way you write is again influenced by the side opposite, but your calculation has to be written in a slightly different way, but same general pattern. What are we getting for our Z and our Y? So Y is going to be 99.59 degrees. And then once we know what Y is, well, we know all triangles add up to 180. And so all I'm going to do is take away the 2 other angles. And for Z, we should get, well, let's have a look. 180 minus 31.47 minus 99.59. And I get 48.94. So 48.94. And so actually, when you have 3 sides, you can use the cos rule to find all 3 angles. It just means that you find one, then you shift the way the rule is written to find another one, and then the last one you can get using the sum of angles in a triangle. So it's actually, your skills are increasing rather rapidly. Okay, now I feel like you've mastered cos rule for sides. I need to provide you with something a little more interesting. So let me go to this question. What is different about this question? And let me start by asking you that. What's different about this question? Find the area of triangle above. Who has some comments that they want to share, some wisdom that they've observed? What's different about this one? I've still got 3 sides. We're not given an angle. Yeah, you're right, we're not. We're not looking for an angle. Well, we're trying to find the area. You're quite right. So we're trying to find the area. Now, the cos rule cannot find you the area of the triangle, but what can find you the area is the area rule. And the area rule says a half times one side times another side times the sine of the angle in between those 2 sides. So now I think we need to have a remix here. I think we have two sides. We need to choose an angle to focus on. Which angle should we focus on? Should we focus on the smallest or the biggest or the middle? Okay, let's focus on the smallest angle. The smallest angle will be opposite the smallest side. I think to find the area, you have a side, you have another side. What you don't have is an angle in between those two sides. But I think you have a way of finding what that green angle is and then using it to help you go on your journey to find the area. So the remixes have begun. We are now bringing together all our knowledge in the toolkit. I'll give you some time, and if there are students getting stuck, please raise your hand and we can chat or you can comment. Should I call this X again, just to make life a bit easier? And what's the exciting one? It's the 8. So what is my angle X going to be? That is the question. Or have you guys moved on already? Looks like. What is the angle? So, well, let me use my calculator so I can catch up here. So 9 squared plus. All right, so I get for my angle 49.46. I mean, I didn't see if anyone else got that, but I think I saw it somewhere. 49.46 is my angle. And then to find the area, I need to take that angle that I've just got, and I need to apply the area rule, which says, now I have to use the 9 and the 10 because that's the angles between that. And then the area I get will just be taking 0.5 or half times 9 times 10 times sine of 49.46. And you should get 34.2 centimeters squared. So 34.2 centimeters squared. Now, this is the first remix question we've done. Give me a thumbs up if you followed how I used the two rules. Give me a thumbs down if you felt a bit lost there. Okay. Because this is where we're going for the rest of today and the next lesson is we're going to start to mix the different rules together. And so let's start. Let's just make sure there's no. Okay, let's go with this. Can you find me the size of angle ABD? So ABD is here, but we have all this information floating around. And so you're going to have to reach into your toolkit and think about, what do I do first? I can't do much in this triangle here because I only see two sides. And unfortunately, two sides isn't enough to do much. So maybe somebody can suggest in the chat what their first step would be in order to find the great red dot. Okay, so for Tejo has said find BD. Yeah, I feel like BD is the bridge between from one triangle to another. And so I would try and find BD if I could. So why don't we ask students to find BD, and then once we found BD, then we can see what we can do. And Paul agrees. So let's set our task. What tool would I use? Can I use the cos rule? I don't think I can, because to use the cos rule, I would need this side and this side. Got this side, don't have that. I think we use the sine rule, and I want a side. So when I use the sine rule on a side, I start by writing it like that. So what is my BD going to be? Yeah, Beverly, what is your question?
Hi, sir.
Hey, yeah.
Well, I wanted to ask if you couldn't use the Pythag theorem.
Okay. So here's the problem. The Pythagoras theorem needs to have a 90-degree angle, and I don't see a right angle anywhere. Like that's not a right angle. That's not a right angle. So because you don't have the 90-degree angle, you can't use the Pythagorean theorem. You're going to use the sine rule, because the sine rule is like very flexible in terms of the way it can be used. And you've got this nice pair of matching sides and angles, and so you can put these two together in an equation. So what do we get for BD? I can do it on my calculator. So we can go 8.4 divided by sine 68, but that's not going to be the answer, because we've still got the sine of 50 on that side. So we need to go times the sine of 50, and I get 6.94 centimeters. Can you now find me angle ABD? I think it's now possible. So over to you guys and girls. Find me ABD. So I'm looking at the chat, and Okunile, Sonic, lots of people are getting 43.53, and I declare that the correct answer, 43.53. And it wouldn't be hard to work out this one over here or this one over here, because you're still just using the same rules, but the question only asked for the red dot, and so we have found the red dot. Very impressed, eh? You guys are handling. Let's do a quick vote. Thumbs up if you're feeling okay. Thumbs down if you're feeling like I'm turning up the heat a bit too quickly. Let me know with the thumbs up, thumbs down vote. Okay. Keep those thumbs coming. Okay, well, I think we've got time for at least one more. Let us try and do this one. So the area of the triangle shown is 25 centimeters squared. Calculate the perimeter of the triangle. So this is going to be our last question for today. And I want to give you time to do it by yourself, but I will allow hints and tips from people who feel like they are in the know. But mostly I want you to fly solo. So off you go. You're given that the area of the triangle is 25 centimeters squared. So that's the area. And you need to find the perimeter of the triangle. And the perimeter is the distance around the outside. So it's like if you were walking around here, you're walking around there. That's what the perimeter means. Okay, over to you guys. Who can suggest a first step in the chat? Maybe somebody is struggling and you want to give them a hint. What hint would you give your fellow student if you were feeling confident about which way to go here? What would you first want to do? Who's feeling generous? Wants to spread their knowledge? Who feels confident enough? Okay, so Andile said write down the formula and substitute. So I'm guessing the formula is the area rule. And generally speaking, the area rule would look like that. You know the area is 25. And you know about this. What you don't know, let's call this angle A. You don't, what is angle A actually? You don't know what this angle is here. And so that's the goal. Can you find what angle A is? So Paul has given us another hint and has said, look, if you find A, you can use the cosine rule to find what BC is. So, but let's first get the A. I was thinking that this stuff gets in the way. And so I'm going to move it to the other side. And then I'm going to get the sine of A. And actually, a half times 8 is 4. 4 times 10 is 40. So I'm really just going to get 25 over 40 because this thing is really 40. And so now I'm just going to use inverse sine. So inverse sine, fraction 25 over 40. And I get 38.68. So So this is the size of this one over here. Now we need to find the BC. Now we're using the cos rule, but we're not using the angle version. What we're doing here is we can call it little a if we like. We're saying that squared, and this is where you may have started to forget this. The format of using the cos rule is going to be, when you're finding the side, it's the same rule, but it just looks a little bit different. And so for our new students especially, you might find, oh goodness, it's still the cos rule, it's just that we're finding a side, not an angle now. And again, the most important thing was the angle that we want is opposite that. And so we'll start with 38.68 there. And then I'd love for somebody to find me what little a is, or you could say BC, it's the same thing. What value do we get for this thing here? So I think it's always the side arms that go there and there. And then I also need to square root because I need to get it to be a. So I go square root . So we get 6.25. And then the last thing is, what is the perimeter? What is the perimeter going to be? So we know that's 6.25. Well, the perimeter is just the distance around the outside. Hit the SD button to make it easier, and it should be 24.25 centimeters. Okay, everyone, we've done really well today. Here, if you could just put the link to the poll, release the poll. I've really pushed you hard today because I really wanted to have a whole nother really well. I was really impressed by your understanding. I mean, like you really have good understanding. And so now what we need to do is polish. We need to have like these compound triangles where we have more information in the drawing, but it feels like your toolkit is ready to be used. So yeah. Amfuna, what is your question?
Sorry, so the equation that you use to find the 6.25,
Okay.
what is the rule?
Yes.
And how does it work?
Okay, this is the cos rule. Pleasure. It's the cos rule written where the sides are the focus. So there's different ways of writing the cos rule. The one is to write it to focus on the angles. So, and that's what I was doing earlier on, where I was saying like the cos of, for example, if we wanted this angle here, or you write it in terms of the angle that you actually want, and then you have it written like this. But then the other way of doing it was where you make the side the subject of the formula, and in that situation, you're going to write down the side that you want squared is equal to two other sides that aren't included so far squared, minus 2 times those angles times the cos of the angle in between. Now, if that feels like a mouthful, it is. I did a whole lesson on it, and I would suggest looking at the recording there.